Welcome back. This is the third lesson recording for IM1 week 7 of distance learning. We've just looked at solving absolute value inequalities. Now we're going to consider special cases of absolute value inequalities. So this is where you need to use logic. Don't just go straight to just following the steps. Think about what you're doing more than just doing the steps. So here you have if absolute value of some expression is greater than negative number or greater than or equal to a negative number. This is a symbol for greater than. Let's think about that for a minute. What does that mean? That means, well, what will absolute value function do? It always produces positive or 0 as its output, right? So I'm going to write that. Or absolute values are always positive or 0. So absolute value is always going to be yield positive or 0 as its output. Is it always going to be bigger than a negative number? Is positive number always going to be bigger than a negative number? Yeah, that is always going to be the true. It does not really matter what the value is here. So it's always going to be true, regardless of what the value of x is. So we say the solution, is all real numbers. Or we can write this fancy R as to denote all real numbers. Okay? Alright, then let's consider what about can absolute value ever be less than a negative number? Okay, remember the absolute value is always going to give a positive number or 0. Can it ever be smaller than a negative number? No, it can never be that, right? It's never. So this is never true. So it does not really matter what the value is here. It's never going to be true. So we don't even have to start going into finding the boundary points or testing anything. You need to straight away be thinking this is never true. So we say it is no solution. Solution is that no solution is our solution. Or we can denote that as this 0 with this number, a line across, diagonal line. This is what we call empty set. It basically means no solution. Okay, so let's try some examples. If I have 2x plus 4, absolute value of 2x plus 4 is greater than or equal to negative 2. Before you go into just following the pattern, following the steps, think about it. Can absolute value ever be not greater than or equal to negative 2? It's always going to be positive number. Then positive number, this is always going to be positive, and this is always negative. Is positive number always greater than or equal to a negative number? Yes, that is always true. So we can say it's going to be all real numbers is my solution. It does not matter what the x is. It's always going to be true. So it's always true. So it's all real numbers. And if I was to graph that on the number line, it will look like this. All of the number line is shaded. And it goes both directions infinitely. Okay, what about the next problem? 3x minus 7, absolute value of 3x minus 7 is less than negative 10. Okay, can absolute value ever produce a number that is less than a negative number? It's never, right? It can't, because this is going to be positive and this is negative. Can negative number ever be bigger than positive number? That's what the inequality is saying. So it's never. So that's going to be no solution or empty set. And if I was to draw that on the graph, it will really be no graph. That's how I would communicate my no solution. There are no numbers on the number line that will make the inequality true. Okay, so up to now we've considered special cases when it is greater than or equal to some negative number. Let's consider what happens if the absolute value expression is greater than 0. So instead of some number, we're talking specifically at 0. Okay, so if the absolute value expression is greater than or equal to 0, let's think about that. Since absolute value is always going to yield positive or 0 as its output, this is always going to be true. So we can say that that's always going to be true. So we can say this is all real numbers. And if I was to graph this, it will be all the numbers on the number line, it will be shaded. Okay, all right. What about if absolute value is of some expression is greater than 0? Remember, absolute value is always going to yield positive number or 0. Well, if it's greater than 0, that means we can't have it be 0. But it's always going to be true. If it's positive, then that's fine, but we cannot have it 0. So the solution is all numbers, all real numbers, except the value that makes the expression 0. The value that makes it 0. So as long as it's not the value that makes it 0 equal to 0, you see, because we don't have the equal sign, we can't have it be 0. Okay? All right, then let's look at what about if the absolute value expression is less than or equal to 0. Can it ever be true? Well, the only time it can be true is if this expression yields 0. Okay? So it is this case only what makes it 0. The value of x variable, that what makes it 0 will be the solution. What about, can absolute value be less than 0? Can it ever be the case? No, it's never. So it's going to be empty set or no solution. Okay, so let's try some examples using this, what we've talked about. So if you have 2x minus 1 is greater than or equal to 0. Okay, well, this is always going to be, this expression is always going to yield positive or 0 as the result of the absolute value function. So that's always going to be true. So that means I don't even have to go anywhere. I can just say it's always going to be true. So all real numbers. And this will be how I would communicate that on the number line. What about second example? Absolute value of 2x minus 1 is greater than 0. Well, usually this is going to yield a positive number, except there is a case when it's going to yield 0. And we can't have that because there is no equal sign. So everything except what makes it 0. So this will be the case, everything except what makes it 0. So what would make it 0? Then that will be when 2x minus 1 is equal to 0. So then you add 1 to both sides, and then you get 2x is equal to 1. So, and then divide both sides by 2. I'm running out of space here. And you get x is half. So that means, to communicate my solution, every number except half will be my solution. So I am going to put an open circle here and then shade the rest. That means everything, all numbers are good except when x is equal to half. Let's try a third example. What about when 2x minus 1, absolute value of 2x minus 1 is less than or equal to 0? Can it ever be true? Well, absolute value is always going to yield positive or 0. So it can be true when 2x minus 1 is equal to 0. So everything that makes it 0. So in this case, 2x minus 1 is equal to 0. So again, it's the same expression as this. So I know that x is half. And how do I communicate that? That is the only time when this inequality is ever going to be true. So it is going to be this circled half and nothing else. So that is just half and nothing else is shaded. Okay, what about this? 2x minus 1 is less than 0. Well, the absolute value function can never yield a positive negative number. So this is going to be never true. So this is going to be empty set. And there is no graph for that. Or empty graph will be. Okay? Okay, now that we've considered all the special cases, we are going to just quickly go through summary of inequalities that we've learned so far. So we know that this symbol means greater than, and if x is greater than some number, it would be represented with a open circle pointing to the right, and greater than or equal to, or closed circle pointing to the right, less than will be open circle pointing to the left, less than or equal to will be closed circle pointing to the left. We also talked about one variable inequality. To solve those, you need to solve just like when you are solving equations. The only thing that you need to remember is that you need to flip the inequality sign if you are dividing or multiplying by a negative number. So you do everything as you would in solving an equation. Just carry over the inequality sign, but you need to flip it like here when you divide it by a negative number, both sides by a negative number, you need to flip the inequality sign. And the solution will be on a number line like this. Okay? And it will be an expression, single expression. However, if you have two variable inequality, like y is greater than 2 over 3x plus 1, you have one variable and two variable, then the solution area is going to be an xy combination. So it's going to be on the coordinate plane, and here you need to graph the line and decide on whether it's going to be solid or dashed line, and you need to shade above or below the line. And then last thing that we covered also was system of two variable inequality. Basically, you graph both inequalities and you are looking for the overlapping area. So this is the solution area because it's the xy combination that satisfies both inequalities. Okay, so that's a quick summary of what we've learned so far. We've also talked about solving absolute value equations, and we talked about solving absolute value inequalities.